let's take an example of a linear polynomial, guys. 7x minus 1. Okay, let's name this as some fx. Okay, so I am interested in finding when fx is positive, guys. So I will write 7x minus 1 greater than 0. Now adding 1 both sides, okay, this becomes 7x greater than 1. Now taking 7 on the right hand side, cross multiplying, it comes in the denominator, so x greater than 1 by 7, it came like this. So I can plot it like this. 1 by 7 is here, okay, and fx positive, fx is positive means fx is plus sign, fx is positive. I will write it like this, guys. Now what is the meaning of this, guys? The meaning of this is, if I substitute any value which is greater than 1 by 7, for example, if I substitute x equals to, let's take a simple value 1, f1. So in fx was 7x minus 1. So if you substitute x equals to 1, 7 into 1 minus 1, it becomes 6, which is positive. So the meaning of this plus sign means the expression fx, the linear polynomial value which it attains for various values of x, is positive. In other words, if you substitute values greater than 1 by 7 in fx, if we substitute values greater than 1 by 7, we will get fx to be positive, which is denoted by this plus sign. So in similarly, for for fx lesser than 0, so fx lesser than 0, what is x? Again, let's say this is part B of this discussion. So there's 7x minus 1 less than 0, again adding 1 both sides and then taking 7 in the denominator, x less than 1 by 7. What we get is 1 by 7 after plotting 1 by 7, x less than 1 by 7. So the left side of the number line 1 by 7 minus infinity to 1 by 7. So fx is negative means we will write it minus sign. Okay, so what we did two parts, which are this. So guys, plus sign means fx is positive when a value greater than 1 by 7 is substituted in fx. This is the meaning of this plus sign. The minus sign means what? Again, fx is the expression, linear expression value is negative. Okay, so similarly, if we take another example like fx is equal to 5x plus 3. I am taking examples in the beginning where the coefficient of x is positive. So again, using the same discussion that we did here for 7x minus 1, for 5x plus 3 as well, I will plot a point at which fx becomes 0, because this is 1 by 7. F 1 by 7, if you see, it is 0. At this point it becomes 0. So the point at which this fx becomes 0 is what? So yes, so fx becomes 0 at 5x plus 3 equals to 0. So x equals to, it becomes minus 3 by 5. So minus 3 by 5, this linear polynomial vanishes. Okay, and again we can plot this sign as plus and minus using the same discussion that we did for fx equals to 7x minus 1. what we did for 7x minus 1, okay, this was the point, this was the point, 1 by 7. So similarly for fx equals to 5x plus 3, we got the point to be minus 3 by 5 guys. Okay, so for various linear factors we get a point on the number line at which it vanishes and then on the right side of that, all the points, all the values of x, if substituted in fx, it will give fx to be positive, it will make fx to be positive, okay, and if substituted all the values on the left side of that point, it will make fx negative in 1 by 7 as well, in case of minus 3 by 5 as well. Okay, we are discussing, as I said, where the coefficient of x is positive. When it is negative, it is reversed. That we will see later guys, or that you can yourself can figure out. So now what if we take two factors in multiplication? We are slowly moving towards something like if two linear factors are multiplied, then we get what? We get a quadratic expression. See, what I mean to say is, if I multiply two linear expressions, we get a quadratic expression. For example, fx, let's say one linear expression is 5x minus 3, 11x plus 2, x minus 1, x plus 3. So if two linear factors are multiplied, we will get what? We will get a quadratic expression. Why we get a quadratic? Because if you solve this, like if you multiply this x into x square, then x is multiplied to minus 1, it becomes minus x, then 3 is multiplied to x, it becomes plus 3x, then 3 gets multiplied to minus 1, it becomes minus 3. So this is a quadratic expression in short. So even if you multiply this by if you multiply 5x minus 3 into 11x plus 2 also, again you will get a quadratic expression guys. Now what we are interested is again in the sign of this. Okay, now one more thing I wanted to discuss about a linear factor, like before moving on to the quadratic one, one thing I forgot. For example, if this is x equals to 7 by 5 and this is plus, this is minus, and fx is guys 5x minus 7 guys. Okay, so then this plus sign means what? Plus sign means it is the solution of this inequality, right? And this minus sign means what? This means it is the solution of this inequality, fx positive, fx negative. Okay, now again moving on to quadratic. Okay, so slowly, gradually we are moving on from linear to quadratic inequality, but before that what we saw was this, which was kind of quadratic expression. Okay, what is a quadratic equation? Quadratic equation is when you equate it to 0. Quadratic equation means like x square plus 7x minus 1, I equate it to 0, this becomes an equation. Simply if I write like this, this is a quadratic expression guys. Okay, this is a quadratic expression. I can name this quadratic expression as fx, gx and so on. So Now we are interested in finding the solution of the quadratic inequality, guys. Okay, so let's take an example. So now we are interested in finding, guys, how do we solve a quadratic inequality. Quadratic inequality means a quadratic expression like the above expression. If I replace it by greater than, less than 0, less than equal to 0. In short, if, or in factor form also, like it is 2x minus 1, 3x plus 4, less than 0, let's say greater than 0, greater than equal to 0. These type of examples are, they belong to what we call a quadratic inequality. On the left hand side, the quadratic expression is there. The generalized format of a quadratic inequality may look like this: ax square plus bx plus c greater than, less than 0, greater than 0, and so on, greater than equal to 0. Okay, so we are interested in solving a quadratic inequality. We will do it by two methods. Okay, now we will discuss method 1, for which I will take an example, guys. So let's do method 1. What is method 1? We are method 1 for solving quadratic inequality, guys. Okay, so method 1 we will discuss by taking an example, guys. So let's say fx is 3x minus 1. So number line I will plot x, this vanishes, fx vanishes at, means fx becomes 0 at x equals to 1 by 3. So I can write for fx equals to 3x minus 1, 1 by 3. Here I will write plus, here I will write minus. Plus indicates fx is positive for all the values greater than 1 by 3, and fx is negative for all the values lesser than 1 by 3. Similarly, if I take another example, let's say gx. Okay, let gx is 2x minus 7. So in the similar way, if I plot 2x minus 7 vanishes at x equals to 7 by 2. So 2x minus 7 can be plotted like this, guys: 2 by 7, or let's say this is, I make it 17. Okay, this is 17 I make, so 17 by 2 it is. So this is 17 by 2. Again I will plot plus and minus. Okay, so we took two examples of polynomial: a fx 3x minus 1, b gx 2x minus 17, and I plotted on both the linear inequality, linear expressions signs on the number line. Okay, now what if we are interested in finding the product of these two, guys? See, what I mean to ask is, if I multiply fx into gx, okay, fx into gx is 3x minus 1, 2x minus 17, 3x minus 1 into 2x minus 17. So I will plot for 3x minus 1, we know 1 by 3, it becomes, it gives plus and minus, okay. So, and for x equals to 17 by 2, okay, 3x minus 1, and this is for 2x minus 17, right? This is what we did, plus and minus. Now if I plot both of them on the same, these 2 points on the same number line, guys, what I mean is 1 by 3 I will plot, 17 by 2 I will plot. Now I am interested in their product, 3x minus 1. What is the sign of their product? 3x minus 1 into 2x minus 17, guys. Okay, so what we will do now, as you can see here, I will join this, I will join this. Now for x which is greater than, now I will write the sign of these two, okay. Now see, here this is plus, this was plus, so here also it is plus, obviously. Now here it is minus, for 2x minus 17 this is minus, so here also it will be minus, okay, right. So now we got 3 intervals on the number line. One of the interval is minus infinity to 1 by 3, and another is 1 by 3 to 17 by 2, and the last one is 17 by 2 to infinity. We got 3 intervals. So now since I multiplied these two, what I will do here, the signs will also get multiplied, minus into minus. See, this is this minus sign, this minus sign, this minus sign I wrote here into here, okay. Similarly, if we take plus, if you multiply plus into minus, what we will get? We will get plus into minus, plus into minus. Similarly, if you multiply plus into plus, okay, plus into plus, if you multiply, guys, plus multiplied by plus sign. So below this line, below this line, I will write the sign of the expression of the product of these two linear inequality, which is a quadratic expression, guys. Linear expressions, if multiplied, they give quadratic expression. So minus into minus, it gives what? It gives plus. Similarly, plus into minus, it will give minus. Similarly, plus into plus, it will give plus. So for 3x minus this 3x minus 1 into 2x minus 17, guys, into 2x minus 17, let's say this is some quadratic expression hx, the sign that we got was this 1 by 3 followed by 17 by 2 plus minus plus, okay. Now in the similar way, if I ask you, let me give you a problem, plot the sign of hx equals to x minus 1 x plus 7 on the number line, on number line. The same way what you did, the same question I am asking you guys on the number line. So what you will do, guys, we will plot each one of the linear expressions x minus 1, okay. I will plot for x minus 1, it vanishes x minus 1 vanishes at x equals to 1. So I will plot 1 here, and again plus and minus I will write. Now again for x equals to x plus 7 I will plot, which vanishes at, means when x plus 7 becomes 0 at x equals to minus 7. So I will plot minus 7 here. It is on the left side of 1, so I plotted it on the left side of 1. Again plus minus. Okay guys, now the same way what we did in the previous example, this I dropped a perpendicular here, from here I dropped a perpendicular here. Okay, now I extended this a bit. Okay, like this. Now again this is minus sign, so here also this is minus sign. So on the left of this is minus as well. Now again here it is plus sign, here it is plus sign guys. So after this also it is plus only guys. Okay, this is 1, this is minus 7. So if you multiply these two in the similar way, if you multiply these two, we will get a quadratic expression x minus 1 into x plus 7, whose signs would be minus multiplied by minus, the same way we did in the previous example, which gives plus sign. This is minus 7, again minus from above, and from x plus 7 it is plus. So minus into plus, it is minus sign, again plus multiplied to plus, you will get plus sign. So guys, this is 1. So for x plus 1 into x minus 7, x plus 7 into x minus 1, the signs are again the same that we obtained for x plus minus plus. Okay guys, so guys, as you can see from the previous two examples, x plus 7, x minus 1, we got the sign as plus, minus, plus. Similarly for 3x minus 1, 2x minus 17, again we got plus, minus, plus. So from these two examples we can generalize that if we have two linear factors are multiplied like this guys, x minus alpha into x minus beta, then if alpha is this, which is the smaller value, beta is this, alpha is lesser than beta, we will again have the same sign, plus, in the middle interval it is minus, in the left interval it is plus. Okay, this is method 1 that we derived by taking two examples. We can derive using alpha beta also, but it would be a bit abstract to understand. So generalizing with the help of these two examples, we can say that for x minus alpha, x minus beta, we get plus, minus, plus. Okay, now what is the meaning of, now how do we apply it in questions like alpha beta? If x minus alpha, x minus beta is greater than 0, what is x? This is the formula that we are writing, what is x? So using this plus, minus, plus, we can say that plus means positive, the expression is positive, so this we will take, and this we will take that which is minus infinity to alpha union beta to infinity. So guys, this is x lesser than alpha or x greater than beta. That is the answer, which is a formula. Other else you can also write it as x belongs to minus infinity to alpha union what? Yes, union beta to infinity. So both ways we can write. So this is the standard result for x minus alpha into x minus beta greater than 0. You can either write it like this or you can write it like this, minus infinity to alpha union beta to infinity. Now if suppose they ask greater than equal to, in that case which 2 points we will include in the solution set? Yes, beta we will include alpha also, and in place of this square bracket, what will come guys? In place of the square bracket, yes, round bracket, square bracket will come guys. So that way for greater than equal to 0, and here also less than equal to alpha greater than equal to beta will come. So in that case the result change would be, here there is square bracket, here also there is square bracket guys. This is the result when greater than equal to is asked for. This is a standard result. Okay, so let's take an example, previous example, 3x minus 1, 2x minus 17 guys. Okay, three x minus 7 2x minus 17 greater than equal to 0. If the question is guys, so as you can see, if you equate 3x minus 7 equal to 0, you will get x equals to 7 by 3, and if you equate 2x minus 17 equal to 0, you will get x as 17 by 2. Okay, so the smaller value we choose as alpha, the bigger value we will choose as beta, and directly we will use this result and directly we can write the answer guys, which is x belongs to minus infinity to the smaller value alpha, which is 7 by 3 closed bracket union beta, which is the bigger value 17 by 2 comma infinity guys. Okay, or else you can write it in inequality form also like this, equivalently x lesser than equal to 7 by 3 or x greater than equal to 17 by 2. That way also we can write. So this we derived using the what we call concept of sign. Okay, using two linear inequalities and multiplied them, and this is one of the method 1 of getting the solution of a linear inequality. Now what if instead of greater than equal to, they ask for less than equal to guys, less than equal to 0. So let's see that guys. So next is x minus alpha x minus beta less than 0. So again, using this alpha beta plus minus plus less than means negative, so our answer would be this alpha to beta. So it means x is, that is alpha to beta, that is the answer. Equivalently, in interval form we can write it x belongs to what? X belongs to alpha to beta open interval. Okay, this is another result. Now what if they ask if it is less than equal to? So if it is less than equal to, beta will be included and alpha will be included. Here also x greater than alpha, it becomes greater than equal to alpha. X less than beta becomes x less than equal to beta. And here in place of round brackets, what we will have is square bracket alpha to beta both included, guys. That's how we will do. So for example, if I take x minus 1 into x plus 6 less than equal to 0, so if you see, it vanishes, this linear factor vanishes at x equals to 1. Another linear factor vanishes at x equals to minus 6. Minus 6 is lesser than 1, so minus 6 would be assigned to be alpha and 1 would be assigned as beta. We can write the answer, we are finding x, we can write the answer as x between minus 6 to 1 using this formula, although this is for equal to, so equal to sign won't come, so we can use this formula, or equivalently we can write it as x belongs to open interval minus 6 to 1. Okay, so that way we can use. Now as you can see here in the formula, alpha x, the linear factors are given to be, the coefficient of x is 1 here, but in this question, in this example, the coefficient of x is not 1. So what I want to emphasize here is this is valid when the coefficient of x is positive. Even if it is not 1 and it is something else, doesn't matter. So that's why here the coefficient was 3, here it was 2, still we can use this formula, and that's why we use this formula in this. Okay, minus infinity to 7 by 3 union 17 by 2 to infinity. Okay, but if x, coefficient of x is negative, that case we will see, guys. Okay, so we will see more examples. So guys, the method one that we did, let's get a quick recap of how we derived it. So first, if suppose a quadratic polynomial x minus 1 x plus 7 is given, so first we will plot it on the number line, guys. So we plotted uh, uh, x minus 1, so x minus 1 we equated it to 0 and we got x equals to 1, so we plotted x equals to 1 first and then plus minus we did. Okay, so we plotted this x minus 1 linear factor followed by the next linear factor which was x plus 7, x plus 7 was equated to 0, and x plus 7 gave minus 7, so minus 7, again plus minus we plotted. Now from 1 we dropped perpendicular, okay, from minus 7 also we dropped perpendicular. So we saw that 1 uh, on the left hand side all the points was negative, gave negative sign to x minus 1. So here also it was negative. So minus 7 on the left side of minus 7 it was negative, on the right side it was positive. Even after 1 also it will be positive. The same for here also, that even after minus 7 on lesser than minus 7 it was negative. So we plotted my x minus 1, x plus 7, these two linear factors separately on the number line, and when you multiply both of them, x plus 1, x minus 1 is multiplied to x minus 7, okay, then what happened is the multiplication of the signs of the two linear factors, minus into minus. Here it was minus, here it was minus, so minus minus got multiplied and we got plus, okay. Similarly here it was minus, here it was plus, so here again it was minus into plus, we got minus. Here it was plus, above also it was plus, so plus into plus, we got plus sign. So we concluded that for the quadratic factors containing two linear factor x plus 7, x minus 1 in multiplication, the sign of that quadratic expression was plus minus plus with respect to the two linear factors, where minus 7 and 1 happens to be the roots of the quadratic equation. Quadratic equation is when we equate them to 0, right? So in the similar way, we took another example, 3x minus 1, 2x minus 17, and we in the similar way we calculated, and again the same signs we got, plus minus plus. It should be noted here that the coefficient of x in both the examples were positive, and in the second example they were 2 and 3, so both were positive. So we generalized it for x minus alpha, x minus beta, okay. Plus minus plus would be the same when alpha is lesser than beta. So x minus alpha, x minus beta, the formula for this is x less than alpha or x greater than beta. And when we used equality here also, we used equality, or equivalently x belongs to minus infinity to alpha, close interval union beta to infinity, okay. So that way we did this. Now this was the method 1, okay. And in the similar way, for lesser than equal to 0, we took this interval from alpha to beta, which we wrote as x greater than equal to alpha, less than equal to beta, or x belongs to close interval alpha comma beta, okay. So we did one example followed by that. Now the second method that we are going to discuss is method number 2 to derive this quadratic formula that we derived from method 1. Concept of sign is quite simple method. This actually we used in method 1 as well. It was plus into minus, minus into plus, negative, here also negative. For example, if 2 is multiplied to minus 3, what we will get? We will get minus 6, which is negative. Similarly, minus 1 by 5 is multiplied to 4, again it is negative. Similarly, this is less than sign, guys. Now plus into plus is what, guys? Yes, it is positive. Minus into minus again is what? Yes, it is positive. Like 2 into 7 is 14, which is positive, Okay, minus 1 into minus 5 is 5, which is positive. We will use the concept of sign for method number 2 to derive the formula of quadratic formula for what? Quadratic inequality result. Okay, so now again quadratic inequality, where we'll derive the results using method 2. So for that again I will take an example, and I will uh, generalize it. But the concept behind method 2, using the underlying principles, underlying concept is definitely the concept of sign. What it is this. Like for example, if I want to derive x minus 2 x plus 7 greater than 0. So what we will see here, that this is positive only when both the factors are positive, or both the factors are negative, because positive positive is positive. This is what the question is asking for, and negative is into negative is also positive. So this is what I call case 1. This I call case 2. As you can see here, or means union. So whatever the result that we obtain from case 1 and case 2, we will take what? We will take the union of the two cases. Now within the case 1, when we solve the first inequality and the second inequality, that will impose both should be positive. So in while solving the first inequality, first case, we will use and. Similarly, for the second case, when the two inequalities must be constrained as minus and minus, so minus into minus means the both should be and. These two inequalities we will use and. So to solve each case we will use and after solving case 1 and case 2, we will take the union, and it will give our final answer. That is the concept behind method number 2. Okay, so x minus 2 x plus 7 greater than 0, we will solve by method case 1 and case 2. Okay, so this question, x minus 2 into x plus 7 greater than 0, we will solve case 1 when both are positive. So plus plus gives positive, so which means that x minus 2 must be positive, which gives x greater than 2, which can be plotted on the number line as 2, and all the values on the right side of 2, it is 2 to infinity, guys. And we will apply the condition for x plus 7. It also should be positive, x greater than minus 7 we will get. And again we will plot minus 7, which is on the left side of 2 since it is lesser than 2, and minus 2 to infinity again. Now since we are using and of since we are using and of these two, so we will, whatever the and result of these two will give the answer of case 1. So and so we will use and, which gives us what? So in order to find and, as you can see, we drop the perpendicular from minus 7 to 2. There, here in the first inequality, there is nothing. In the first inequality, there is nothing. However, in the second inequality, there is something. So the end result would be nothing. So from minus 7 to minus 2, there won't be any answer. Okay. Now if you see from minus plus 2 to, if you see from plus 2 to infinity, and here also plus 2 to infinity, both have the answer common, which is plus 2 to infinity. So the intersection would be plus 2 to infinity in this case. Okay, so the answer of case 1 is x greater than 2. Okay, this is answer of case 1. Now for the case 2, what we will impose? Yes, minus into minus. Okay, so for case 2, minus into minus should be positive. So x minus 2 should be negative, and x plus 7 should be negative. X minus 2 less than 0 will give you in the next step x less than 2, and if you plot on the number line, it would be lesser than 2. Okay, so x lesser than 2, it is like this. All the values minus infinity to 2 we will take. Similarly, x plus 7 less than 0 gives x less than minus 7, and if you plot on the number line, since it is lesser than 7, minus 7 is lesser than 2, it would be on the left side, so it would be minus infinity to minus 7. Now we will take again the AND of these two, and now as you can see here, if you take AND of these two, okay, from minus 2, from plus 2 to minus 7, what I mean is this, guys. Minus 7 to, from minus 7 to 2, there is nothing here. From here there is something, so there is nothing here. Okay, though there is no answer from minus 7 to 2. Now from minus infinity to minus 7, and here also minus infinity to minus 7, both have common solutions. So the answer in case 2, it would be what? Minus infinity to minus 7. So answer of case 2, guys, would be what? Case 2 answer would be x less than minus 7, guys. Okay, so the final answer is what? So the final answer would be the union of what? The case 1 answer and case 2 answer. So case 1 answer, what we got was x greater than 2. Case 2 answer, x less than minus 7. So final answer is x belongs to, I will write this first, minus infinity to minus 7, then followed by answer here, union 2 to infinity. So guys, as you can see here, so in this example, x minus 2, so in this example, guys, x minus 2, x plus 7 greater than 0, what we obtained was, it was lesser than minus 7 and greater than 2. So for a generalized quadratic inequality having two factors, x minus alpha, x minus beta, alpha is lesser than beta, both are real, so it will be from lesser than alpha and greater than beta. means x lesser than alpha or x greater than beta, or in other words we can say that x belongs to minus infinity to alpha union or beta to infinity. That way we can generalize it. Okay, and in case when there is equality here, like so, like this, when there is equality here, so in the answer this less than also will be replaced by less than equal to, greater than would be replaced by greater than equal to beta. Here dark circle will put at alpha and beta, and as you can note here, we replace the open bracket by the close bracket. So minus infinity to alpha included, union beta comma infinity, guys. So that way we can do it. Let's take one example on this. X is 2x square minus x minus 2 greater than equal to 0. Find x. You can try this. Okay. So if you think about this, I will give you the hint first. The hint to this problem is factorize it using Sridharacharya. Factorize. Okay. And then use the formula that we derived above formula we can use. So factorize using quadratic formula, okay, or using splitting the middle term. Factorize using Sridharacharya or quadratic formula, or factorize using splitting the middle term, and then use the above formula. So let's go to the solution to this. So if you see 2x square minus x minus 2, we cannot factorize it, because if you multiply the coefficient of x square and the constant term 4 cannot be multiplied in such a way to give answer as +1 or -1. So splitting that middle term is not possible. So what we will do, we will factorize this equation using quadratic formula. Okay, using quadratic formula. What is quadratic formula, guys? It is x equals to minus b plus minus under root b square minus 4ac upon 2a. So what is a here? A is 2, b is -1, c is again -2. C is -2. So if you substitute the values of a, b and c, so minus of -1, b will substitute, then b square is -1 square minus 4ac, a is 2, c is -2 upon 2a, a is 2. So the value of x is 1 plus minus under root 1 plus 4 2s are 8 2s are 16 upon 2 2s are 4. So it is 1 plus root 17 by 4 comma 1 minus root 17 by 4. So these are the two values of x. The bigger value would be, let's say this is beta, this is alpha. So this quadratic 2x square minus x minus 2 greater than 0 okay, greater than equal to 0 is factorized as what? It is factorized as 2. I will take out x minus alpha, x minus beta greater than equal to 0. The leading coefficient 2, and if you multiply by 1 by 2 both sides, this will be 2 by 2 greater than equal to 0 by 2. 0 upon 2 is 0. So the multiplication of a positive constant doesn't matter. Okay, so it becomes this only, and x minus alpha, x minus beta greater than equal to 0. From the formula we know that it is x is greater than equal to alpha or x is less than equal to beta. So that is directly the answer we can write. Now we will substitute alpha as what? We assigned alpha as 1 minus root 17 by 4, or x less than equal to 1 plus root 17 by 4, guys. And in interval form we can write it like this: x belongs to minus infinity to 1 minus root 17 by 4, closed interval, square bracket union square bracket 1 plus root 17 by 4 to infinity, open bracket. So this is the final answer. Okay, guys. Now proceeding with the same concept of sign, in a similar way we can derive x minus alpha, x minus beta less than 0, and it comes out to be the same that we did in method 1. And in a similar way, if you derive it using second method, it comes out to be the same, which is alpha beta plus minus plus minus plus. So alpha to beta it will be, in other words, the answer is x alpha to beta, or else we can equivalently write x belongs to open alpha to open beta. Okay, so x minus alpha, x minus beta less than 0, the answer is x greater than alpha less than beta. Equivalently, x belongs to open interval alpha comma beta. Now in case if equality is there here, then equality will be here also, and this square bracket would be replaced, open brackets, round brackets would be replaced by close brackets, guys, like this. So let's take another example on this. X square minus 5x less than equal to 1. Find x. So how we will do, guys? So again the hint is same. Factorize using either splitting the middle term, split the middle term, or using quadratic formula or Sridharacharya formula. Okay, so factorize what? X square minus 5x minus 1 less than equal to 0. So you have to factorize this equation in the form of the roots alpha and beta. So roots we can find by, as I said, using either quadratic formula or splitting the middle term. Now this we cannot split the middle term, so we will solve it. So we will solve using quadratic formula. We will solve using quadratic formula, the equation x square minus 5x minus 1 equals to 0. So the formula is again the same, minus b plus minus under root b square minus 4ac upon 2a. So where a is the coefficient of x square, b is minus 5, the coefficient of x, the constant term is minus 1, that we will substitute here, minus of minus 5 plus minus under root b square, which is minus 5 square minus 4 into 1 into minus 1 upon 2 into 1. So using this we will get the two values, 5 plus minus under root 25 plus 4 upon 2, which gives us x equals to 5 plus minus root 29 by 2, which is x equals to 5 minus root 29 by 2, 5 plus root 29 by 2. So the lesser value, we know that we assign them alpha, we assign them beta. So x minus alpha, x minus beta less than equal to 0 we will use, whose answer is x greater than equal to alpha less than equal to beta. So alpha we will substitute as 5 minus root 29 by 2, and beta we will substitute 5 plus root 29 by 2. Equivalently, the answer would be x belongs to 5 minus root 29 by 2 comma 5 plus root 29 by 2. That would be the answer, guys. So we have seen that x minus alpha, x minus beta greater than equal to 0, less than 0, equal less than equal to 0, and so on. We have seen the results. Okay, now what if the coefficient, like the coefficients were positive so far, like for example if we take 2x minus 1 into 3x plus 4 greater than equal to 0. So in this case, guys, if we have to find x, so as I said, we can use the same result, alpha beta x minus alpha x minus beta greater than equal to 0, even if the coefficients are other than 1, here like in example 2 and 3. Now the reason is, like if you are not convinced that why we can use for this, you can take 2 common from this. So this becomes x minus half. You can take common 3 from this. So this becomes x plus, it becomes 4 by 3 greater than equal to 0. Now 2 into 3, 2 into 3 becomes 6, x minus half x plus 4 by 3 greater than equal to 0. Now multiply by 1 by 6 both sides. In this we will get what? 6 by 6 cancels out, and now it is again of the same form as that of the given formula, x minus alpha x minus beta greater than equal to 0. And in the similar way we can find the points at which each of the linear factors vanishes. So x equals to half and x equals to minus 4 by 3 are the points at which it vanishes. So the result would be, first we will plot the 2 points. Minus 4 by 3 would be on the left since it is the lower value, 1 by 2 on the right side, again plus minus plus, and since the question is asking for plus, we will take greater than half value lesser than minus 4 by 3 value, that is minus infinity to 4 by 3 union half to infinity. Since the question is asking for half, so greater than equal to, we will include this and this, which is same as if you directly equate 2x minus 1 to 0 and 3x plus 4 equals to 0, and directly you can get this instead of me using this. Okay, this is a way to convince you that whatever might be the coefficients, as long as they are positive, we can use the same formula as this. Okay, for greater than or less than. So guys, now the question arises, what if one of the coefficient is negative? What I mean to say is, if for example, if I take x minus 5, 2 minus 3x less than 0, for example, now we have to find x. Now as you can see here, the coefficient of x in this is negative, guys. Here the coefficient is negative. So what we will do, we can multiply by minus sign. Okay, so what we can do, we can multiply by minus 1 both sides and see what will happen. And then when a minus sign is multiplied, minus 1 we will tag with the second factor, because only one minus 1 is multiplied, guys. So this becomes what, guys? In the next step, this, since minus 1 is multiplied, this becomes greater than 0. The sign is reversed. Okay, so minus 1, since it is multiplied, this minus 1 is multiplied to this linear factor, and it makes it as minus 3x becomes plus 3x, plus 2 becomes minus 2, sign becomes greater than 0, and so on. You can solve. Okay, and accordingly, like x minus 5 becomes 0 at 5, 3x minus 2 becomes 0 at 2 by 3, 2 by 3 5, plus minus 5. In the same way we can proceed the way we did in the previous examples. Okay, so only we need to multiply it by minus 1 both sides, it will change the sign. Or else, if one of the coefficient is negative, then what you can do is, instead of using less than answer, you can take greater than answer. Instead of not multiplying by minus 1 directly, you can write the answer for plus if one of the coefficient is negative. Okay, I will illustrate it by one more example. Like if they are asking for 1 minus x, 2x minus 5 greater than equal to 0. So since here, as you can see, the coefficient of x is negative here, we can directly write, since they are asking for plus greater than equal to 0, we can directly take right answer for minus. What I mean to say is, directly, no need to write the shortcut, no need to write multiply it by minus 1s that we already did in the previous example. Simply what you do, you will first get the points at which each of the linear factor vanishes, which is the first step that we always do, and followed by plotting them 1 5 by 2 and again plus minus plus. Now instead of taking plus sign, guys, instead of taking greater than equal to greater than, which is asking for plus, we will take minus. we will take the opposite, because one of the coefficient is negative, and since they are asking for equality, we will take 1 and 5 by 2 in the solution. Okay, in the solution set. So answer would be x belongs to 1 comma 5 by 2. You will get the same when you multiply by minus 1. If you follow the same concept in this example, x minus 5, 2 minus 3x less than 0, multiplying by minus 1, you will get in the same example if you follow the same. So once you understood, no need to do it by multiplying by minus 1, simply take this, the reverse sign answer as final answer. Now what if both the coefficients are negative, guys? For example, if I take what happened, just a minute, guys. If I take minus x minus 4 into 5 minus 3x greater than 0, in that case, as you can see here, both the coefficients are what? The coefficient of x in both the examples are negative. Here also negative, here also negative it is. So what we will do, we will take minus 1 common from each of them, guys. Minus 1, from minus 1, if you take out, it becomes x plus 4. Here also, if you take minus 1 out, it will become 3x minus 5. This is greater than 0 is as it is. Now this minus 1 gets multiplied with this minus 1, it becomes minus 1 square, x plus 4, 3x minus 5 greater than 0, and this becomes x plus 4. This becomes minus 1 square becomes 1, 3x minus 5 greater than 0, and as you can see, the result of this is same as the result of this. These two results are same. So this is basically, if both have negative signs, it is equivalent to the same scenario if you take cancel the minus sign from each one of the linear factors. So now you can directly write the answer. This x plus 4 vanishes at minus 4, 3x plus 5 vanishes at 5 by 3, it becomes 0 at 5 by 3, again plus minus plus, so it becomes this, it becomes this. So it is greater than 5 by 3, minus infinity to 4. So that way we can write. So what I want to say is this, guys. If both the coefficients are negative, you can treat them as if the question is when the minus 1 is taken out, or minus 1 is multiplied to each of the linear factors. Let's take one more example. If it is minus 1 minus 8x, 4 minus 5x, 4 minus 5x less than 0. So it is, this is same as 1 plus 8x taking minus out, here also taking minus out, 5x minus 4, sign is same. Okay, so then again you can plot 1 plus 8x vanishes at minus 1 by 8, 5x minus 4 vanishes at 4 by 5, plus minus plus, so answer would be minus 1 by 8 to 4 by 5. Okay, both excluded. So guys, if I ask you x square greater than equal to, let's say 3 square, how we can solve this? What I mean to say is, what is x? So Can we do it like this? X and taking under root plus minus 3 and so on. Is this approach right? So guys, in case of equation, this is what we used to do. X square equals to 3 square. Then we used to write in the next step as x is either 3 or minus 3. But here this we cannot do because there is no such rule like this. So this approach is wrong. So the correct approach would be, guys, since it's a quadratic, we will take x square minus 3 square on the right hand side, 3 square on the LHS, it becomes minus 3 square. Now factorizing it, x minus 3 and x plus 3 using a square minus b square greater than equal to 0. Then again plotting the points at which each of the linear factor vanishes, that is when x minus 3 is 0 at x equals to 3, and when x plus 3 is 0 at x equals to minus 3, again using concept of sign plus minus plus. Now since it is asking for greater than, so it means it is asking for plus, so we will take plus. So this would be our answer, minus infinity to minus 3 plus infinity 3 to plus infinity. So guys, our discussion for this example, x square greater than equal to 3 square, it finally concluded was this is x is greater than equal to 3 or x is less than equal to minus 3, guys. So in the similar way, instead of 3, if I write a number, alpha, generalizing this, okay, so alpha is what, guys? Alpha is positive. In the similar way, using taking alpha square on the left hand side, factorizing, plotting it on the number line and so on, we will get this, guys, and this is the general result of this. We can write it as a formula, x square greater than equal to alpha square is x is greater than alpha or x is less than equal to minus alpha. So this is the generalization of the above formula, okay. So x square, equivalently x belongs to minus infinity to alpha. What is alpha? Alpha is a positive number, alpha to infinity. So guys, this is a standard result, x square greater than equal to alpha square, which is either x is greater than equal to alpha or x is less than equal to alpha, okay, or we can write it like this, guys. Now in case if equality is not there here, it won't be here, it won't be here. One more thing I forgot, actually it should be greater than sign. Since equality is there, this should be included, guys. In case if equality is not there, we will place round brackets instead of square brackets. So x square greater than equal to alpha square, this is the solution, and this is quite frequently used in questions. Let's take a simple example. Now for example, if it is x square greater than 12, here I haven't taken equality sign. So what we will do in the first step, we will write 12 as what? Square of what? So 12 is, guys, 2 square into 3, okay. 12 is what? 2 square into 3. So 12 can be written as 2 root 3 square. So we can write 12 as 2 root 3 square, and directly we can write the answer as x belongs to minus infinity to 2 root 3. So here alpha is what? Here alpha is 2 root 3, guys. So minus infinity to 2 root 3 closed union, sorry, minus 2 root 3. Here also it should be minus alpha, sorry guys. Okay, so alpha, which is 2 root 3 in this case, to infinity, guys. So that's the answer, guys. Okay, now what about when instead of 12, if it is, let's say, some negative number, like for example x square, before taking 12, what if it is 0? So alpha is 0 in this case. Okay, so guys, alpha is 0. You can say that this is an identity, guys. This is an identity. Sorry, if it is greater than equal to 0, let's say, so we can use the formula also, or if you can't, if you don't want to use the formula, by reasoning, by correct logic, which goes like this, that any number whose square is, any real number, the square of that number x square is a positive number. So positive number is greater than equal to 0 is a truth. Okay, even if x is 0, if you substitute x equals to 0, this becomes, guys, what? 0 greater than equal to 0, which is also true. So x square greater than equal to 0 is rather, I shouldn't say it's an example, it's an identity. X square greater than equal to 0 is basically an identity, which is x belongs to R, equivalently x belongs to minus infinity to plus infinity, guys. Okay, this is what? This is an x square greater than equal to 0 is an identity which is satisfied by all real numbers. Okay, what if x square what if x square, if I ask you greater than 0, for what x this will hold? X is what? So guys, we can say that x square, since it's a positive number, it is greater than 0, so which is true. But if x equals to 0, if you put x equals to 0 here, 0 greater than 0 would be a false statement. So for x square greater than 0, what we can say? X square greater than 0, we can say that x is all real but excluding 0. Or we can equivalently, we can write x is what? X belongs to minus infinity to 0 open union, again open 0 to infinity. That way also we can write x square greater than 0. Okay, guys. So for example, if I ask you, what is the solution of 3x minus 1 whole square greater than 0? Tell me. So you can use this above fact. So obviously here also x can be anything, but if you substitute a point where 3x minus 1 vanishes, which is 1 by 3, so at x equals to 1 by 3, if you substitute, this 3x minus 1 whole square becomes what? 0. Okay, so in that case 0 greater than 0 would be false. Any other value, for example, if you take x equals to 1, this becomes 3 minus 1 whole square greater than 0, which is 2 square, 4 greater than 0, which is 2. Any other value apart from x equals to 1 by 3 would be true. So again, the solution of this is same as what we did in the above, deriving the identity. It would be all real excluding the value of x for which the square value vanishes, that is x, all real excluding 1 by 3. That is the answer to x 3x minus 1 whole square greater than 0. Okay, but if I ask you 1 minus 7x greater than equal to square greater than equal to 0, so again, since this is a square of a number which can be 0 also, so using the identity x square greater than equal to 0, we can directly use. So what do you say the answer should be? So yes, directly we can say that even if x is 1 by 7 or otherwise, it will hold. So x belongs to R would be the answer, guys. Okay, so that way we can say. Now what if, guys, if I ask you, let's say instead of 3x minus 1 whole square greater than equal to let's say minus 9 minus 81, let's say if I take minus 81, then how do we, what is x? How do we solve this, guys? So my question to you is, can we use that result that we derived, that was x square greater than equal to a square, can it be used here? Alpha square, x square greater than equal to alpha square, which is x greater than equal to alpha, or x minus infinity, x less than equal to minus alpha, can we use that? So answer is yes or no. So yes, guys, the answer is no, we cannot use this. Why? Because alpha square is a positive quantity, but minus 81 is a negative quantity. So alpha square minus 81 we cannot use. This we cannot, for this formula we cannot use. So in that case, what we will use? We will use a general reasoning here, guys, that see 3x minus 1 whole square greater than equal to minus 81, if you see, this is a any value, any x, if you substitute, this will be positive number, or it can be at the least 0, and here it is fixed minus 81. So even if it is positive, the left hand side of the inequality, even if it is positive or 0, it will always be greater than, or this greater than thing will always be satisfied. Okay, this greater than thing will always be satisfied. Equal to won't be satisfied, doesn't matter. So we can say that this is true. So any value of x, this is an identity, x belongs to R. We can say that this is valid for all x belonging to R. Okay, what if I ask you 3x minus 1 whole square greater than minus 81? I have replaced, I have removed this equal to sign here. What you will say now? What x now, guys? Obviously you will say that the formula cannot be used, but yes, again, if you put any x, this will be positive or 0, which is greater than minus 81. So this is what, in any case, whether 3x minus 1 whole square is positive or 0, this will always be greater than minus 81. So this is true. So yes, we can say in this case also the answer would be all real, x belongs to R. Okay, so guys, now moving on to the next thing. In the similar way, the way we derived x square greater than, in the similar way, if you take factors x square less than equal to alpha square, if you take factors and use number line and so on, you will get that x is from minus alpha to plus alpha. Equivalently, x belongs to minus alpha to plus alpha, guys. And when in case when x is instead of less than equal to, if only it is less than, then what would be the formula, guys? So it would be when it is less than. So as you can see here, if here it is only less, then here also we will take less than, and here this would be replaced by round brackets instead of square brackets, guys. Equality sign, if it is missing here, it would be missing here as well. Okay, so let's take some examples on this. So for example, x square less than equal to 7. So yes, guys, we can write it, since this is alpha. Okay, you can say that this alpha is positive here. Okay, so alpha square is also positive. So x square less than equal to 7 can be written as root 7 square. So now in the next step, using the result, using the formula that we derived, we can write it as minus root 7 to plus root 7, or equivalently x belongs to minus root 7 to plus root 7, guys. Okay, so what if, guys, let's take another concept now. Instead of x, if there is some fx whole square less than equal to alpha square, instead of x there is some function. What I mean to say is fx can be a linear function, that is for example 1 minus 3x, a linear function. It can be some trigonometric function, let sin x, tan x, cot x, inverse trigonometric function, logarithmic function, exponential function, any function. Even if it is, we can use this as formula, like fx is less than equal to alpha, so we can write it as minus alpha to plus alpha. So this can be generalized further. F square x instead of x square, if it is fx square, where fx can be linear, any function, guys. These are some of the examples that I have written. So it would be minus alpha to plus alpha. Okay, so and so on, etc. The other functions cannot be there instead of fx. So for example, let's take a linear function square, let's say 3x minus 1 whole square less than equal to 36. Let's solve for x. So guys, try this. So guys, what we will do, we will use this formula where 3x minus 1 whole square, here alpha square is 36. So what is alpha, guys? Yes, alpha is 6 square. So again, we should refrain from using 3x minus 1 as plus minus 6, because we have practiced a lot in linear equations to take square root and using plus minus. This we won't do. We will use the formula. So guys, this is fx. So fx is here 3x minus 1. So it is not x, is some fx. So again the same formula can be used. So using this above, fx is also minus alpha to plus alpha, where fx is linear function here. So it would be 3x minus 1 lies between what? Yes, minus alpha, which is minus 6, to plus alpha, which is plus 6. Now this kind of equations what we do, two equations simultaneously are linear inequalities are there which can be solved simultaneously by removing 1 here and then coefficient of x here to get the value of x. So what we will do, we will add both sides plus 1, all the three sides of the inequality as plus 1. So what we will get, guys, minus 6 plus 1 less than equal to 3x minus 1 plus 1 less than equal to 6 plus 1. So yes, when we add 1 it becomes minus 6 plus 1 minus 5, minus 1 plus 1 gets cancelled, 6 plus 1 becomes 7. Now we will, in the next step, we will multiply by what to get x? So yes, we will multiply by 1 by 3 both sides. So this extreme side becomes minus 5 by 3, the middle one becomes 3x by x by 3, right hand side becomes 7 by 3, 3 gets cancelled out, and we will get x as minus 5 by 3 to 7 by 3, guys, which is the answer. Okay, so that way we can do. So in the similar way, guys, if instead of less than equal to, guys, if it is greater than equal to, guys, so in a similar way we can use fx greater than equal to alpha or fx less than equal to minus alpha, guys. This is again a generalized result of what? X square greater than equal to alpha square. Okay, so x is replaced by fx. Fx can be a function, okay, but we will use linear function here only. Okay, other things would be done later. Okay, so let's take an example on this, guys. So I will give you one question on this. So like 2x plus 3 whole square greater than equal to let's say 27. Solve this, guys. Okay, so yes, the hint would be this only. You will get fx square greater than equal to a square, which gives fx greater than equal to a, or fx less than equal to minus a or alpha. Okay, alpha let's take. Okay, so here fx is what, guys? So the solution fx is 2x plus 3. So what is alpha here, guys? 27. If you take under root plus under root of 27, okay, because we will take alpha to be positive only, okay, it would be 3 cube, so we can write it as 3 square into 3. So alpha is, guys, under root of 3 square becomes plus 3 root 3. Alpha is 3 root 3. So now we can use this formula, fx greater than equal to alpha square. So using this result, we will directly substitute in alpha and fx here. So after substituting, we will get f2x plus 3, which is fx greater than equal to 3 root 3. Okay, or 2x plus 3 less than equal to minus alpha. So minus 3 root 3 we will write, guys. So 2x adding plus minus 3 both sides, 3 root 3 minus 3 here also, or 2x plus 3 minus 3 minus 3 root 3 minus 3. So this cancels out. We will get left with 2x greater than equal to 3. We can take common 3 root 3 minus 1, or here also 3 minus 3 cancels out. We get 2x less than equal to, here what we can take common, minus 3. So inside we are left with root 3 plus 1. So now we will multiply by half. So x greater than equal to 3 root 3 minus 1 by 2. Here also we will multiply by half, guys, into half. So this becomes what, guys? 2x by 2, which is 1, minus 3 by 2 root 3 plus 1, guys. So the answer is what, guys? In interval form, if you write this, it would be x belongs to minus infinity. This, if you write here, minus 3 by 2 root 3 plus 1. Now the upper part, if you write here in union, it should be a close bracket, guys. Here also it should be close bracket. It should be 3 root 3 minus 1 by 2 comma infinity open. That would be the answer to this, guys. Okay. Now let's take, we saw some basic identity, x square greater than equal to 0, greater than minus alpha square. What if in the similar pattern, if I ask you x square less than equal to 0, what is x? So guys, as you can see, this is x square is a positive number. If you substitute any positive or given negative number, less than 0, it won't satisfy. Equal to 0 also it won't satisfy. So this will always be false statement. Only one possibility, when x is 0, it will satisfy 0 less than equal to 0, which would be true, isn't it? So we can say that x square less than equal to 0 means x is 0 only. It is only one solution. Okay. Now what if x square, so in the similar way, if I ask you 7x plus 11 whole square less than equal to 0, what is x? So again, any value of x, if you substitute, okay, it will give positive, which is less than 0 would be false, equal to will also be false. But one possibility we can check, when 7x plus 11 equals to 0, it vanishes. It vanishes at x equals to what? X equals to minus 11 by 7, guys. So in that case, if you substitute, then 7x plus 11, this would be what, guys? This would be 0. This would be 0 less than equal to 0, which is true. So we can say that x equals to minus 11 by 7, or the value of x at which that linear value vanishes is the only solution, guys. Okay. So now what if, guys, if I ask you 7x plus 11, I will eliminate, taking the previous example, continuing with that, I will replace the equality sign, okay, with I remove the equality sign. Now it is less than 0. Now if I ask you what is x, x is what? So guys, this is, we know, as discussed, this is a positive number, Okay, whatever real value you assign it to x is less than 0. Okay, positive is less than 0 is a false statement. So any value of x won't satisfy this inequality even if you substitute x equals to minus 11 by 7, guys. Okay, even in that case also minus 11 by 7, this becomes 0 less than 0 will again be true or false. Yes, in this case, guys, it would be false. So we can say that this kind of inequalities, there is no solution, x belongs to phi, no solution, or it is inconsistent, no solution, same. Okay, so we can generalize it by a basic identity x square. If they ask for less than 0, no x satisfies this, guys. Okay, no x satisfies this, no x, or x belongs to null set, which is phi. So guys, if I ask you x plus 1 whole square plus 1 greater than 0, find x. So x plus 1 whole square greater than 0, you can think, you can reason in two ways. The first reasoning goes like this, that this is always positive, or or at the least this can become 0, or 1 is a positive quantity. So positive plus positive, if you add these two, you will get positive value, okay, which is greater than 0, so therefore it's an identity. So it is valid for what, x? Yes, x belongs to R. That reasoning, this reasoning you can use, or else you can think of taking this x plus 1 whole square plus 1, let's take plus 4. Okay, so doesn't matter plus 1 or plus 4, but I took plus 4. Okay, so plus 4. Second reasoning, we can think of taking 4 on the right hand side, which becomes minus 4. Okay, now this is always positive because it's a square of something. Whatever you put x, whether positive or negative or minus 1, it will give positive, or at the least it will give you 0 when x is substituted as what? Yes, when x is substituted as minus 1. So overall it is positive or 0. So this is left hand side of the inequality is positive or 0. The right hand side of this inequality is negative, minus 4 is negative. So overall the situation on the left hand side is positive, then this greater sign, and in the right hand side is a fixed negative value minus 4, so which is also an identity, guys. So again this holds for x belongs to R. Okay, now if you see, so answer is x belongs to R. Now x plus 1 whole square. Now let's take another aspect of this question, x plus 1 whole square. If I ask you what is this quadratic, if I ask you this quadratic expression, what is the discriminant? You know, guys, discriminant you might have seen in lower classes, like b square minus 4ac. Discriminant is when b square minus 4ac for a quadratic ax square plus bx plus c. Okay, so here if I write it, if I check the discriminant of this, first I will open this, and then 4 plus 1, it will give you 5. So x square plus 2x plus 5. Now if I check the discriminant of this, where a is the coefficient of x square is 1, b the coefficient of x is 2 and the constant is 5. Substituting here, d is equal to b square minus 4ac. So b square means 2 square minus 4ac, 4 into 1 into 5. It becomes 4 minus 5 4s are 20, which is minus 16, which is negative, guys. Okay, so any quadratic equation, guys, whose discriminant is 0, sorry, whose discriminant is negative and coefficient of a is positive. Okay, so if I write any quadratic expression like this whose discriminant is negative and a is positive, the same as the previous example, it can be proved by using perfect square, by converting this expression into perfect square, that this is positive for all x belonging to R. What I mean to say is the solution of this is all R. This is an identity in x. This is an quadratic identity when discriminant is negative and a is positive. Okay, this will always be positive, guys. So let's take one more example. X square plus 4x plus 10, okay, greater than 0. So as you can see here, if you can check the discriminant of this, since coefficient of x square is positive, which is 1. Now if you check the discriminant here, we have to find x. So if you check the discriminant, which is b square, a is 1, b as you can see is 4 and c is 10. B square minus 4ac, b square minus 4 into 1 into 10, which is 16 minus 40. Okay, so directly you can write negative instead of calculating. Okay, this is negative, or minus 24 you can calculate also. So it is negative, so x belongs to R you can write. Okay, this is what we concluded. And why we concluded it? Because we can, if you convert it in perfect square, it is easy to justify why x belongs to R satisfies this. I will rewrite this question as x square plus 4x plus 10 greater than 0. Now converting into perfect square, converting into perfect square, x square, 4 I will write 2 into x. So 2 square I will add, 2 square I will subtract. Okay, now from here, this and this is of the form a square plus 2ab plus b square, which becomes x plus 2 whole square. Now this is minus 4 plus 10 greater than 0. So x plus 2 whole square plus 6 greater than 0. So as you can see here from the reasoning that we did in the first example, x plus 2 is positive plus 6 positive, so this whole thing is positive, which is greater than 0 obviously. So x belongs to R is this. So this is used, this basic fact, that when discriminant is negative, provided the coefficient of x square is positive, the quadratic expression is always positive. Or we can say that this quadratic expression, if you impose greater than 0 constraint, it will be valid, it will be satisfied for all x belonging to R. Okay guys, so in questions, when there are so many factors involved, if there is a quadratic factor having uh, uh, like if you take a question like x square plus 4x plus 10 into x minus 3 less than 0. For example, if you have to solve for x, okay, so how do we do this? So since we are, so we can use that the discriminant of this is negative. So this will always be, this expression, this quadratic expression will always be positive, okay, into x minus 3 negative. So since this quadratic expression irrespective of any value of x is positive, the second factor in multiplication, which is x minus 3, it gives negative. So it means this factor, the second factor x minus 3, should be imposed with which sign? So yes, it should be negative, because since this is positive, this has to be negative, so that their product positive into negative gives negative. So this implies x minus 3 is less than 0. So the solution would be x is less than 3. That is the use of this fact. When discriminant is negative and coefficient of x square is positive, the quadratic expression is always positive, and accordingly we can solve an inequality. Okay. So let's take an example. 16 x to the power 4 less than equal to 81, find x. How we can attempt this, guys? So first approach that you may think, 16 we can write 2 ki power 4 x ki power 4, 81 we can write 4th power of what? Yes, 3 to the power 4. So we can write it as 2x whole to the power 4 less than equal to 3 to the power 4. Can we cancel this? And then we can write it in the next step, 2x less than equal to 3. So x is less than equal to 3 by 2 as our answer. Or in the second approach, we can write 2x to the power 4 minus 3 to the power 4 less than equal to 0. Then a square minus b square we can write 2 square x square to the power 4 minus 9 square less than equal to 0. 3 to the power 4 I have written as this. A square minus b square is a square, a minus b, a plus b. That way we can write. So which approach is correct, guys? First or second? So guys, the thing is, this first approach, this is wrong. This we cannot cancel. This step is wrong, guys. This step we cannot cancel. Means if a to the power 4 less than a to the power b to the power 4, we cannot write a to the power a less than equal to b. Okay, from this to this is not allowed, guys. So clearly this answer is also wrong. So the first approach is wrong. So we will continue with the second approach. After writing it as 2x to the power 4, you will take 3 to the power 4 on the left hand side. Again rewriting them as 9 square and 2 square x square whole square, a minus b, a plus b, and further we can solve. Okay, so when you solve it further, as you can see here, this is 2x whole square minus 3 square. This is 4x square plus 9 less than equal to 0. Now we know that this value, this expression, since x square is there which is positive, 9 is there which is positive, you can also check the discriminant. Discriminant is also negative of this. It would be minus 4 into 9. Okay, so this whole expression 4x square plus 9 is what, guys? This is positive always. So since this is positive always, using concept of sign, this the first factor 2x whole square minus 3 square, this has to be negative. Okay, this has to be negative. So, and this is positive always. Okay, the second factor, this one. So this has to be, it has to be negative. It has to be negative. So in the next step, what we can write is this 2x whole square minus 3 square less than equal to 0. Okay. You can also say that 4x square plus 9 will go in the denominator. 0 upon 4x square plus 9 becomes 0. Because it's a positive quantity, we can cross multiply it without changing the sign of the inequality. So that way also it can be argued. Now 2x whole square minus less than equal to 3 square. Now x square less than a square that we can use, which is x minus a to a. This result we did. So we can write it like this, 2x, this is capital X, which is 2x, a is 3 here, so minus 3 to plus 3, multiply by half, you will get minus 3 by 2 to x 3 by 2, 2 and 2 gets cancelled. So x minus 3 by 2 to 3 by 2 would be our final answer. Minus 3 by 2 to 3 by 2. Okay. So that's how we can approach. We will see more rules where a to the power n less than equal to b to the power n. What is the relation between a and b? If can we remove the power, that we will see later. Okay. Now let's take another example, guys. X cube minus 3x square plus 12x greater than 0. We have to solve this, guys. So what we can do, what should be our approach? What is the hint? So guys, take x common and you will get a quadratic inside. If you can factorize it, you can try factorizing it. Okay, and then you can solve it further. But the thing is, x, when you take this quadratic, let's come to the solution now. This quadratic, as you can see, this quadratic has discriminant what? Yes, this quadratic has discriminant, as you can see here, b square, which is minus 3 square minus 4 into 1 into 12, 9 minus 39, which is negative, guys. Okay, so discriminant is negative. So this quadratic is positive always. Okay, so x multiplied by a expression which is always positive, multiply greater than 0 gives when? Since this is positive, it means this has to be positive, right? Then only positive into positive gives positive. So in the next step, we can only write x greater than 0. Okay, this has to be positive, and this is the answer, guys. Okay, moving on to the next example. So what we did, again we use the concept of sign and the fact that when discriminant is less than 0, the quadratic expression is always positive and the coefficient of x square is 1, which is positive. So we use that fact. So let's take another example, guys. X upon x square minus x plus 2 greater than equal to half. So how we can solve this? So guys, the first approach, it seems like x upon this quadratic, you will take minus half and then we will solve. But for that, when you solve it, you have to use wavy curve method that we will see later. Okay, wavy curve. And the quadratic, that also we have to see whether it is factorizable or not. Okay, this is one of the method. But the second method that I want to emphasize now is, as you can check for this quadratic, the discriminant b square minus 4ac 4ca is negative. So guys, this expression plus 2 is positive for all x belonging to R. So since this is always positive, what we can do here in this question, x upon x square minus x plus 2, since this is always positive, we can cross multiply it here without affecting or without changing the sign of the inequality, and 2 can be cross multiplied here. So although in the previous examples I warned you, I told you that terms containing x variable we cannot cross multiply because we are not sure about the sign of that particular expression. But since this quadratic expression is always positive because its discriminant is less than 0, we can cross multiply here. So when you cross multiply 2 on LHS, it will get multiplied to the it will get multiplied to x, and x square minus x plus 2 gets multiplied to 1. So now we can, this reduces to something what we did, which is a quadratic inequality. 2x will go on the right hand side of the inequality, and x square minus x minus 2x plus 2. Okay, so this x minus 2x gets added, it becomes what? Minus 3x plus 2. Equivalently, this is x square minus 3x plus 2 less than equal to 0. If you factorize it, x square minus, or you could have directly factorized it here itself. Okay, instead of adding minus x and minus 2x. Anyways, this x square minus, so here itself we can factorize it. Okay, so x square, we can take x common, so it will be x minus 1, then we'll take minus 2, so x minus 2 less than equal to 0. So x minus 1 will come out, this is minus 1, it's not minus 2 guys. X minus 1, x minus 2 less than equal to 0. Now using x minus alpha, x minus beta, plus minus plus 1 and 2, we will choose this minus sign. So 1 to 2 is the answer. Okay, x belongs to closed 1, 2, both included. Okay, so that way we can do.